Okay, so today what we're going to be looking at is reviewing for your quiz over simplifying and solving trig functions. If you don't get all this right at the beginning, this is going to be uploaded on YouTube. The sub should put the link on the whiteboard so that you can see and be able to write that down, so you can go back to and look over this as much as you want tonight so that you'll be good to go for tomorrow. So let's go ahead and get started. All right, so the first type of problems we're going to work with here are being able to simplify these trig functions down to either one term, like sine theta or tangent theta, or one of the other 6 trig functions, or a constant, meaning like a number, like 1, 2, so forth. Okay? So now to do this, remember we had those 5 tools we used, okay? One being change everything to sines and cosines, right? So we can simplify. Change everything to sine and cosine. Sine or cosine. Okay. Second one were those Pythagorean identities. Okay, we'll talk about those a little bit later. But we've got those. The third one were those cofunction identities, which in the next example we'll talk about these. Okay. The fourth thing we did was either factor or GCF, and that really kind of doubles with the last one. It's just a special kind of factoring, which was, okay, was those difference of 2 squares. Okay. All right, so now if we have these 5 down, we know what they are, we can start to use them. Okay, so let's look at this problem here. This is one of those cofunction identities, knowing that tangent of 90 minus theta is going to be the same thing as cotangent of theta. So this is cotangent of theta, right? Okay, then we take a look at this. Cosine of 90 minus theta, remember, is the same thing as saying sine of theta. So what I've got is cotangent of theta times sine of theta. Okay, so now our next step here would to be able to maybe write this one, okay, write the cotangent one as a sine or a cosine, and see if that'll help me simplify anything. Okay, so what we're going to have here is going to be cosine theta over sine theta times sine theta over 1. Okay, so when we do that, these reduce to 1, and what I'm left with is just cosine theta. There's your answer. There's your simplified down to 1 term. You're good to go. Okay, so moving on. Now, second type of problem is using the Pythagorean theorem identities. This is key, okay? As you've heard me say all week, understanding this equation is very important, okay? So what I mean by let's practice deriving all these other identities from this one equation, let's first just kind of look at how I could rearrange this sine squared plus cosine squared theta equals 1, so that I could solve for just sine or just for cosine, okay? So say we moved the cosine over, okay? We subtracted the cosine, and I'm left with just sine squared theta equals 1 minus cosine squared theta. Okay, we can do that kind of thing. Or if I do it the other way around and subtract the sine, I can have cosine squared theta is equal to 1 minus sine squared theta. Okay, any one of these 3 I can just pick out of this one equation. Okay, so now let's talk about how we can get tangent and cotangent out of this stuff. Okay, so like we said before, everything is made up of sines and cosines. Everything that we've used is made up of sines and cosines. We just have to be able to manipulate it. So say we take our basic equation, okay, that we've got here, okay, this basic equation, and let's divide everything by cosines. So cosine squared theta, divide by cosine squared theta, divide by cosine squared theta. Okay, this is going to give us another one of our Pythagorean identities. Okay, so sine divided by cosine is tangent squared theta. Cosine divided by cosine is plus 1 equals secant squared theta. Okay, this is another one you need to know. That's the second one. Okay, and you got to be able to manipulate it. Like if I say secant squared theta minus 1, I need you to understand that that equals tangent squared theta. Okay, so now instead of dividing by cosine, okay, let's take this same equation, okay, same idea here, okay, and now instead of dividing it by by cosine, let's divide it by sine. Okay, so I'm going to divide everything by sine squared theta. Okay, and when I do that, I end up with 1 plus cosine over sine is cotangent squared theta, and this equals cosecant squared theta. Okay, this is your third one, third and final one on those Pythagorean identities, to be able to move these things around. Okay, now I also need you to be able to tell me that if I said cosecant squared theta minus cotangent squared theta, that should equal 1. Okay, or I need you to be able to say cosecant squared theta minus 1 equals cotangent squared theta. Okay, these tools will help you manipulate and move things around whenever we get into solving, or whenever we're just trying to simplify some of these tougher problems. So, okay, so now we're going to move on to some simplifying. Okay, so what I would do here, okay, is go ahead and FOIL this out, because I might get a squared out of it. I might be able to deal with one of my Pythagorean identities. Okay, so if I do 1 times 1, okay, that's going to be 1. 1 times secant is plus secant theta. Here times 1 is minus secant theta. Okay, and this times here is going to be minus secant squared theta. Okay. Okay, so now what we've got is we can cancel these two, and we've got 1 minus secant squared theta. Now, this is that other tool that we've been using, is that difference of two squares, because we see how the middle term cancels out. I'm left with a perfect square minus, okay, a perfect square minus another perfect square. Okay, sometimes we need to separate that out and make it look like what it is up at the top to help us simplify as we go back and forth. Okay, now 1 minus secant squared theta, okay, is going to be one of our Pythagorean identities. Okay, so if you're having trouble, remember secant. Okay, secant theta is dividing by cosine. To divide by cosine means it's going to be sine over cosine, so this has to be tangent squared theta. There's your final answer. Okay. Okay, now this is another example where we're going to be able to use some factoring, and we're also going to be using our Pythagorean identities. Okay, so right off the bat, I can tell that this sine squared theta plus cosine squared theta, that's going to be 1. So I've got 1 times whatever this is going to be. Okay, now we notice that this has tangent in common. So what I can do here is factor out a tangent. So I'm going to take tangent out, okay, and then I'm going to be left with this secant squared theta, okay, minus tangent squared theta. Okay, so now again, see how we've got all tangents here, right? Tangent and tangent, but how could I rewrite this so that it also is a tangent? Okay, we go back to our Pythagorean identities, and we know that this is going to be tangent, okay, 1 plus tangent squared theta, okay, minus tangent squared theta. Okay, that's what this on the inside is going to be. So these two will end up canceling each other out, and I end up just having 1 times tangent theta times 1. So this whole thing is just tangent theta. Okay, these make these a lot simpler whenever you understand your Pythagorean identities. Otherwise, you're sitting there trying to change things to sines and cosines, and makes this one really sloppy. So really look over those Pythagorean identities before tomorrow. Okay. All right. Now, in this situation, okay, the Pythagorean identities aren't going to help me as much. Okay. So this is a situation where I would write things out as sines and cosines. But before I do that, okay, whenever I've got a plus like this, I would probably deal with this first, deal with this inside part first, okay, and try to get just one fraction, okay? So let's go ahead and kind of work this one out, okay? So if cotangent is going to be cosine A over sine A, and then plus sine A over cosine A. Okay, but to add, we got to have common denominators. Okay, so this side, to make it look like this side, needs to be multiplied by cosine A on top and bottom. Okay, to make this one look the same, I need to multiply it by sine A. Okay, so when I do that, cosine A times cosine A is cosine squared A over cosine A sine A plus sine squared A over cosine A sine A. Okay, so now that they have the same denominator, I can put all of this into one fraction. I can make it cosine squared A plus sine squared A over cosine A sine A. Okay, now I see a squared, so that would tip me off, okay, that this might be a Pythagorean identity, and it is. Okay, this whole thing on the top becomes just 1. Okay, so now we go back to our beginning, right, where I can write this as tangent A times 1 over cosine A sine A. Okay, now we go back to our toolbox and we try to figure out, okay, what can I do now? Well, this one's in the 1 over cosine A sine A is all in sines and cosines, so I might need to change this. Okay, so I'm going to do sine A over cosine A times 1 over cosine A sine A. Okay, the sines are going to reduce, and then I have cosine A times cosine A, so I end up with 1 over cosine squared A, which is secant squared A. You're down to your single term. You're good to go. Okay. All right. Now, as we move on here, let's look at this. Now, this problem here, I'm looking at this because that's Pythagorean identity. We know that that is going to be cosine squared b, right? From our sine squared b plus cosine squared b, we know that that is cosine squared b, okay? Then we're going to divide this by cotangent squared b, okay? And when I do that, I need to change this bottom piece into sines and cosines. So I'm going to have cosine squared b times, or really divided by, sorry, cosine squared b over sine squared b. Okay, so whenever I do this, this bottom part is going to flip and we're going to multiply. So I'm going to have cosine squared b times sine squared b over cosine squared b. Okay, so the cosines cancel out, right, because that's over 1. And I'm left with just sine squared b as my answer. Okay. As we kind of move forward here, now we've got a reciprocal problem, okay? Now, you could change this into sines and cosines, but there is a simpler way of looking at this, okay? Remember how these are related, okay? Sine and cosecant are reciprocals of one another. So when I multiply reciprocals, I always just get 1, okay? Cosine and secant, those are also reciprocals. So I'm going to have 1 plus 1. It's as easy as your first grade teacher taught you. 1 plus 1, 2. There's your answer. Okay. Moving right along here. Now we're going to get into the solving. Okay, so whenever I solve for between 0 and 360, if it's written like this, you should assume that you're going to be doing things in degrees. Okay, so I'm looking for a degree answer here. Okay, so as we walk through this, okay, we've got to remember our unit circle. Okay, this unit circle. Okay, remembering that all my trig functions are positive in the first quadrant, sine is positive in the second quadrant, tangents in the third, and cosine is positive in the fourth. Okay, and you've got to remember your trig ratios. Okay, draw those triangles if you need to. Okay, the 30, 60, 90, and the 45, 45, 90 to help you out. Okay, where this is 1 square root of 3, 2. This is 1, 1 square root of 2. Okay, so now let's just get into this and try to start solving this thing. Okay, so and there should be a theta here. Okay, so first thing I'm going to do is going to add the 5. So I'm going to have 4 sine squared theta equals 1. Okay, so then I'm going to divide by 4. Okay, and I've got sine squared theta equals 1/4. Now this is the key. Whenever you take the square root here, to get rid of that squared, it's got to be plus or minus. Okay, so now I've got sine theta is equal to 1/2. Okay, now whenever we deal with this, what angle would give me a sine ratio of 1/2? So I look at my triangle over here, sine of 1/2 is 30 degrees. Okay, so I know that I've got, and I just missed the mistake too, plus or minus 1/2, right? Because I'm going to have sine of 1/2, theta equals 1/2. And then I've got to solve for sine of theta equals negative 1/2. Okay, so theta in this one is going to be 30 degrees. But where else is sine positive 1/2? You've got to remember that this angle also, okay, is positive. Okay, so the reference is 30, so 30 degrees away from 180 is 150 degrees. Okay, and then over here for negative, that's in the third and fourth quadrants. Okay, so those reference angles are going to be 210 degrees and 330 degrees. Okay, so these are your 4 answers for this problem. Okay. Now, when I look at a problem like this, it looks really confusing, but first let's start off with is just remember whenever I see between 0 and 2 pi, okay, that means I need to be in radians. Okay, whenever I'm working in radians, that means that's that, pi over 6, we've got to be able to convert. Okay, now the first problem here is that I'm not all in the same term, right? I've got cosines and I've got sines. Okay, whenever I'm trying to solve, I really want to try to get them down to one type of trig ratio, if I can. Okay, so, but I do remember something about this. Okay, let's think about what that is. 1 minus cosine squared b is the same thing as sine squared b. Okay, so now I've got sine squared b minus 8 sine b plus 7 equals 0. Okay, so now what it looks like, if I took the sines away, okay, and I just made this an x, okay, that looks kind of like a quadratic, right? Well, we can always factor quadratics, right? What 2 numbers multiply to 7 that add to negative 8? Okay, and instead of using x, we're going to use sine. Okay, so those 2 numbers are negative 7 and negative 1, so our factoring looks like this. Sine minus 7, or sine, sorry, b minus 7 times sine b minus 1 equals 0. Okay, now I can set each one of my factors equal to this 0. Okay, so I have sine b equals 7 and sine b equals 1. Okay, so again, always go back to your unit circle, right? Now remember, your unit circle is just what it means. This is only 1 unit. Okay, so this is impossible for me, okay? I'm not going to have sine b of 7. But now I've got to figure out where sine of b is 1. And remember, our y values are our sine values, so it's going to be up here at 90 degrees. Well, 90 degrees as a radian is pi over 2. That's your only answer for this one. Okay, it's pi over 2. Okay. Okay, well, if you're able to do these problems, okay, you should be okay for the quiz tomorrow. Okay, good luck. You'll be fine. If you want to watch this video again, the YouTube link should be on the whiteboard for you to jot down and for you to be able to search on YouTube. So good luck, and I'll see you guys Monday.